So I did give this opening speech, but I really don't think anyone heard me. But I would like to welcome everyone out. My name is Tyrone Wilson, the founder and president of Cover6 Solutions. Today we have the fine folks from Uberry, Chris Myers and Barrett Adams, here to give us a presentation on PowerShell Empire. I'm sure it's going to be a great presentation. Feel free to ask questions, get comfortable with the GoToWebinar control panel, the questions section. And what we'll do is we'll get it started. If you missed it, it will be posted to the Cover6 website and the Cover6 YouTube channel. So what I'll do right now is I'll hand it over to Chris for the presentation. Thank you all for coming out. Chris, you have the floor.
Great. Thanks, Tyrone. As Tyrone mentioned, I'm Chris, and I'm here with my colleague Barrett, and we're going to be giving a presentation here on the basics of command and control as it pertains to penetration testing, and that's kind of the first half of the presentation, and then after that we'll be going over some practical examples with PowerShell Empire and getting into the weeds of that particular C2 framework. So Barrett and I both head up a company named Uberry, and what we do there is we build simulated corporate networks for our clients, so students and professionals, to learn both penetration testing and defensive cybersecurity. My background is as a red teamer, penetration tester, doing mostly internal networks and web application assessments.
Hey everyone, I'm Barrett. Also come from essentially the same background as Chris, doing penetration testing and red teaming. Really enjoyed that and wanted to do something to give more people access to that industry and an easy way to come into it. So it's where we started Uberry from. Anyway, we'll dive right in here. So this is a quick overview of what we're going to be talking about today. Go over the basics of command and control channels, the parts involved there, and then look at PowerShell Empire, how we set up that command and control channel, and a bit of what we can do afterwards, the post-exploitation of once we have that communication set up, how we can attack the host we're on and the network around that. So this is kind of the most basic C2. You need a server side, the attacker side that is, a compromised side with an agent on it, which is what talks back to the attacker's server, and then just some communication in between. Now these can get extremely complex, so this is an example of a real world one that a couple Russian APT groups used, just to give you an idea of how many components can start happening in these.
Yeah, and this diagram doesn't even do a great job of really showing the whole infrastructure here. Like one node in this diagram is potentially many different systems involved in the C2 communication, so they get really crazy.
Anyway, to look into what that C2 communication looks like, there's a couple different types of connections. Can kind of be broken into two categories based on the direction that that connection is initiated, bind and reverse. We'll dive into those in a second. And traffic types, this is kind of unlimited, but here's a couple of the popular ones. We're going to focus on HTTP today, but you can really send C2 traffic over any protocol that you can control. So a bind connection. We've got our server side, and we've got our compromised host with our agent on it. We're not going to talk about how that agent got there today. That's either through exploitation or phishing or walking up to a computer and typing it in, whatever it may be. There's a lot of routes there, and that's certainly an important part of the kill chain, but we're going to presume that one way or another, this host has been compromised and focus on the next steps here. So in a bind C2, that compromised or the server will send commands to the compromised host, and the compromised host will send the output of those commands back to the server. So for this to work, the compromised host needs to be accessible to the server. So if you're talking about two unconnected networks, that generally means the compromised host would have to have a port open to the internet that the server could reach. Reverse is the same effect, but in the other direction. So the compromised host will initiate the communication by checking for commands from the server, which will respond with those commands. And then the compromised host again sends the output of any commands back to the server. So this is very helpful for getting out of a network where you may not have a port on the internet that attacker box can reach. So for instance, most normal networks, your computer is behind a NAT gateway or other firewall type arrangement. So it can reach out to the internet, but random things on the internet cannot reach it. So with this type of connection, that computer can reach out to the server on the internet, which once that connection is open, can reply. So to see this with a protocol we've all heard of, HTTP, the compromised host makes an HTTP request to the server, just like it was looking up a website. But instead of getting a website back, it gets, here's some commands I'd like you to run, and then another request to pass that output back to the server. This is just a screenshot of what that HTTP request and response actually looks like with Empire traffic. So the red is coming from the compromised host, just a request to the Empire server, and then a response back. And not much in the response because there were no commands in this example that the server had, so just empty.
Yep. Yeah, and you can see pretty much any of these parameters in the GET request there or in the response can be sending data. So you can customize what this looks like with Empire and with the other frameworks to say ask for commands and specifically the session ID cookie and respond with them in one part of the body. So you can do some things with your HTTP profiles to try to avoid detection. This is an example of default Empire behavior, and this traffic's almost always going to get caught by any defensive tools.
So another cool protocol of C2 communication here, using DNS. So here the compromised host is going to perform a DNS query, both for checking for commands and whenever it's passing data. Now, instead of sending that directly to the server, the attacker side, it's going to send that to whatever its default DNS server is, whether that's an internal server on the network or Google's 8.8.8.8, whatever it is. Now, that query is for a domain name that the server, the attacker box, is set as the authoritative DNS server of. So that means when this default DNS server doesn't have the value, it will forward that request to the attacker box, which lets the attacker box reply with a DNS response. That could be an IP address, or if it was a text record, a small string of text, which then gets forwarded back to the requesting computer, which is our compromised host here. This can be very useful for getting out of restricted networks because you're talking to a computer that gets talked to all the time, and the request gets forwarded from there instead of having to reach out directly to this attacker server that has never been reached out to from the network before.
Yep, that, and also there's a lot more detections in place generally for web HTTP traffic than there are for DNS requests, and it's kind of harder to filter out malicious DNS traffic than it is to filter out potentially malicious C2 traffic from HTTP requests.
Also worth noting here, because it's over DNS, the size of these requests and responses is very limited. So it's going to take a lot of requests and responses to transmit the same amount of data relative to HTTP, which means it's going to be a much slower communication channel. Just some other protocols that are somewhat common. SMB gets used for internal communication on networks, especially between Windows computers, like file shares and between applications that need to talk to each other on different computers, that kind of thing. So using that on an internal network fits in with the other traffic and makes it hard to detect. And generic TCP or UDP connections are also popular enough just because they're so vanilla and easy. So something like Netcat, just connecting between two ports, is a generic TCP connection. Which brings us to a couple examples of C2 implementations. So these are different tools that will run a command and control channel for you. Netcat isn't a C2 tool per se. It's more a networking tool that can do all manner of things, but it's flexible enough that you can use it to set up communication between two computers. PowerShell Empire, we're going to focus on that today. Cobalt Strike is a paid C2 and post-exploitation tool, somewhat similar to PowerShell Empire, but you get a bit more features and a very nice graphical interface for paying for it. Metasploit, I'm sure you've heard of before, has C2 in it, but also tons of other modules and exploits and whatnot. So why PowerShell Empire today? It's free and open source, so that means you can all go download it and play with it yourselves. It's pretty popular. Certainly find lots of pen testers and red teams using it. We have a bunch of experience in it, so that certainly helps for us being able to write a how-to here for you. And PowerShell makes it very flexible, especially in Windows environments. PowerShell is very good at talking to Active Directory and internal Windows components, so that helps a lot during the exploitation phase of things. Now, I'm going to pass it over to Chris here to dive into Empire some more.
Thanks, Barrett. All right, so as Barrett mentioned, PowerShell Empire is an open source post-exploitation C2 framework. So that means it's got a lot of different developers. It's actually a pretty big project. You probably recognize some of the Twitter handles there for some of the developers. And then it's also got modules ported in from a bunch of external tools. And that's kind of the bulk of what you do after the C2 traffic is established. You're going to use all those external modules to do additional stuff. All right, they've also got excellent ASCII art. So definitely one of those developers is solely focused on doing ASCII art for this thing. But there are five main components here, excuse me, of the Empire platform that make those C2 basics work that Barrett just talked about. So listeners, launchers, stagers, agents, and modules all are separate pieces of Empire that work together to establish communication between your attacking server and the compromised host, and then do various activities on the compromised host and its network. The first thing we're going to talk about here are listeners and launchers. So these are pretty closely related, but a listener, we're going to specifically talk about the HTTP listener today because some of the other listeners, it's just a bit more complex. So for simplicity and time, we're going to use HTTP today. But the HTTP listener will specify the protocol that the Empire C2 traffic is going to use. And like I mentioned, it has that default Empire profile. So you can do a lot with it to change that. Some of the important attributes of an Empire listener are its name. So this is kind of arbitrary, but it's important to know because you're going to be referencing the listener by name in a lot of the other pieces of Empire. And then you have the host, and this is definitely the most important attribute. So the host is your attacking server IP or host name, or the host name of some other redirector that's going to eventually get the traffic to your system. So without the right host in this parameter, your listener is not going to hear any of the C2 traffic coming back from your compromised hosts. You can define what port to listen on. So for HTTP traffic, we usually just leave this at 80, so the traffic looks more normal, but you could also put it on an arbitrary port or something like 8080, so kind of an alternative web port. And then you also configure the launcher, which is configured by default for you, which is very nice. With launchers, there's two types. There's PowerShell and Python launchers, and both of these use either PowerShell or Python to execute an encoded command and download the rest of the PowerShell Empire agent and launch it on the system. So the launcher is what you're actually going to use on your compromised host to create that malicious agent process that's going to handle all of your C2 traffic. Both types of launchers can be used in Windows or Linux, but it's much more common for PowerShell to be used on Windows host and Python on Linux because they come there by default a lot. So some of the listener options here, I already mentioned. This is a screenshot mainly for people that missed part of the presentation or want to look at this afterwards. So you can see all the different options here, the launcher, the host, name, and then this is the example of the launcher. So it's, like I said, a rather large encoded command that you're going to run just with PowerShell in this case. So both of launchers and stagers are going to create that C2 traffic. So a stager is slightly different than a launcher because it's going to be a standalone file. So whether it's a macro that you put in an Excel or a Word document, or an HTA file, a Windows executable, or there's a few other different options that you can use. But these are going to be somehow delivered to your compromised host and executed on there, and essentially it just uses whatever file to execute a launcher and establish that agent. So these are the options for the stager. This is a macro stager for the example. So you can set the listener, you can obfuscate your payload, which Empire's default obfuscation isn't that great, so we kind of just leave it how it is anyways. But you can set a few different things here. And then when you generate the macro, it'll just write that to a file, and then you have to go take that and configure your payload. All right, so like I mentioned, both the stagers and the launchers and the listeners, they all work together to establish an agent. So the first thing we're going to do as an attacker on our attacker box is to configure that listener. So once we have the listener configured, we can use either a launcher or a stager on our compromised host. And when that executes, it's going to create that agent process for us. And then the agent process is going to handle all the C2 communication from that point between our attacker box and our compromised host. That's kind of how those pieces work together to create an agent. All right, so I'm going to go into Empire here now and show you what configuring some of that stuff looks like. And we can walk through doing the listener and launcher and eventually creating ourselves an agent. So this is the Empire main screen here. To configure a listener, first you have to type listeners, and there aren't any currently active. So what we need to do is tell Empire to use a listener, and then you specify the type of listener. So we're going to do HTTP. But you can see if you tab complete this that there are also a bunch of other types of listeners. You can even do Meterpreter here, which is the Metasploit agent through Empire. We're going to use the HTTP listener. And then once you're in there, you can type info to see all of your options. I think these are all preset for us. We have the name, our host is my host there. Some things like the default profile you set here, and also the port's good, that's 80. So to start this listener, you type execute, and that's going to start the listener for you. Once the listener is started, you'll see it show up in your list of listeners. So the HTTP there, you can see it's running an HTTP listener on our host. And the next step is going to be to create a launcher or a stager from this. To do that, you can simply type launcher, specify which listener you want to use. First, you have to specify if you want to do a Python launcher or a PowerShell launcher. So we're going to use PowerShell because it's easy and we're working with Windows. Specify your listener and hit enter. So this is a really large blob and it's pretty annoying to copy and paste places sometimes. But we're going to go ahead and try to copy and paste this. And I just have a ready to go PowerShell prompt up on the Windows host we're going to be compromising. So we'll see if I can't copy and paste this over. All right, so I'm going to run that on our host over here, which you guys can't see. And then what you should see here is that initial agent being created. So once you have an agent, you can go to the agents menu and look at all your agents there. You can see I've already made a backup agent in case this demo went not so according to plan. So before we interact with that agent and talk about them, I'll show you the stagers real quick. So there's a bunch of different stagers here that you can use. So you can make a bat file, a macro. If you've heard of the rubber ducky from Hack5, you can make a rubber ducky payload and put it on one of those. And you can do some Linux stuff and some multi-platform options as well. We're going to use the Windows macro here as our example. So there's not too much stuff to configure here, but you do have to make sure to set the listener. And to set an option in Empire, you simply type set, then the name of the parameter that you want to configure, and then the value that you want to set. Once you have that, you can generate the stager. You go and it's going to write it to a file here, and you can also have it output to the screen if you want, but sometimes these tend to be pretty big and messy. So just to show you what that macro looks like, it's essentially just a VBA script that you would configure in Word or Excel to create a macro with. And you can see here that it's essentially just creating that PowerShell string, the same encoded command that our launcher uses. And it's going to run that on the host that executes that macro. All right, so we have our agent now. So agents are the malicious processes that run on the compromised host, and they do all of the orchestration between your compromised host and your C2 server. So they can do a bunch of stuff kind of built in without using any modules. So you can run different shell commands like list contents of the directory or list running processes, check what user that your agent is running as, pretty much all the normal command prompt behavior it can handle. And then from within your agents, you can also change some of its default behavior. So you can change how often it checks in. The default for Empire is 5 seconds. So it's going to check back with our server every 5 seconds. because this is a reverse connection. So that agent checks back in, waits for commands, and then checks in again 5 seconds later. But if you wanted that to be a minute or 2 minutes or something to be a little less noisy, you could change that. And then Empire also has a pretty interesting configuration option that most other platforms don't, called working hours. And what those are is you can set when you want your agent to be active, essentially. So if someone you've compromised, you know they work 9 to 5, and you want all of your traffic to happen when they're actually using their workstation, you can set the working hours of the agent from 9 to 5, and it's only going to check back with your C2 server during that window. Last thing that agents can do are run modules, and those are going to be the real powerful stuff that we'll show you in a second. This is just the help list for when you're inside an agent, so you can see you can do some basic commands there. You can get info about the agent. You can run shellcode right from the agent, which is nice. There's some shortcuts in here to different modules like Mimikatz and PS and Jet. And then from in there, you can also list all of your processes and that sort of thing. So we can go in and show you what the agents look like. So to interact with an agent, it's pretty much the same as with Metasploit from Interpreter, if you've used that at all. You type interact, and then you select the agent that you want to interact with, and that gets you inside of the agent. You can type help anywhere in Empire actually and see what commands you can run. We can list the processes, or we can check who we're running as. So what this is going to do is respond with our domain user there, Chris A. And now we know that we're that user. We can do something like list the processes on the system. There's a lot of processes running. All right, so that's kind of the basic agent capabilities without any modules. But where they really shine is using these PowerShell Empire modules. So what the modules are additional capabilities for the agent. So there's a ton of them. There's definitely not enough. There's too many to go over today with you, but these 4 categories pretty closely align with your standard pen testing kill chain. So they have situational awareness modules, privilege escalation, credential gathering, and lateral movement. So you can really learn a lot about your environment. You can become an admin if you aren't already, grab people's passwords, and then use those passwords to move other places on the network. So some of the situational awareness modules we can go over. So there's generic network situational awareness. So you can, once you've compromised a host, you can do port scans and reverse DNS lookups to kind of identify other interesting systems on the network that you might want to attack. And you can also do a lot of Active Directory enumeration. So you can ask to pull the users in Active Directory or all of the groups. You can run a tool called Bloodhound, which is going to do a whole host of Active Directory enumeration and eventually attempt to tell you your shortest path from the compromised host that you're currently on and the user that you have to eventually moving all the way around the network to gain domain admin. And then if you wanted to target a specific user, say to log into an application that has some sensitive data you want to access, you can do individual specific user hunting with this module as well. So like I said, there's a lot of situational awareness modules. We're just going to go over, show you the port scan and some of the AD group stuff. So to use any module in Empire, just like the other commands, you say use module. And then since we're doing situational awareness, you type out situational awareness, you can do network and port scan. So the port scan module is going to take a bunch of optional parameters, but really all you need to tell it are what hosts you want to scan and the agent to run with. And you can also tell it, which I always do, to only respond or only show you the host with open ports. So we can run this. It's going to start a job on our agent. That job's going to run, do the port scan, and then it's going to report back to us with the results. Hopefully. One of the things you'll come across with C2 is that you have to be very patient sometimes. Things get real finicky, and sometimes they don't come back when you expect them to, and sometimes they don't come back at all. So there's a lot of experimentation to be done and a lot of weirdness that goes on. But if you're lucky, you get your output like this. So we see this is the host that we just scanned, and it's telling us it's got open ports on all of those ports right there. So some remote desktop, other Windows services, and web ports. So that might be a host that we want to check out if we were doing a penetration test. Some of the other situational awareness stuff that we can do is author a module based off of PowerView. So this is an external PowerShell tool that does a host of Active Directory enumeration. So they've moved it into PowerShell Empire here, so you can do almost all of the functionality of PowerView is built into various Empire modules. So get group is going to have a whole bunch of stuff here, but if you just run it with the default, or with only the agent configured, it's going to pull back all of the groups in the domain. So this is important when you're trying to identify potentially privileged users that might have access to certain applications by going after different groups. So you can see here that ran, it says get domain group completed, which is the name of the PowerShell command that it's actually running on the host. And it's going to pull back all of the local, or all of the domain groups here. So you can see Sugar Admins is the Active Directory group that has domains for a CR, or local admins for a CRM. And the output's kind of messy, but it's pretty detailed anyways. Those are some of the situational awareness modules. There's also privilege escalation modules. So right now I'm running actually as a domain administrator. So I have all the privilege that I can essentially. But a lot of times when you compromise a host, you'll have just a regular user account and you won't have any administrative privileges. So in order to escalate your privileges to an administrator, you can run some of these modules built into Empire to try to escalate to an admin. So PowerUp is another external tool, a PowerShell tool, that's going to check the local host for a bunch of different misconfigurations that might allow you to run something with elevated privileges. Bypass UAC is a module that will, if you already have admin rights, but your agent isn't running with admin privileges, it'll try to give you those admin privileges by bypassing the little prompt that shows up whenever you try to run something with higher privileges on your laptop. And then you can also try to exploit specific vulnerabilities. So if there's a missing Windows patch on the system that there's an exploit for, Empire might have that, and you could potentially run that to get an agent with admin creds. Once you run the privilege escalation or somehow otherwise get admin rights, you can start doing some cool stuff like gathering credentials. So gathering credentials on a compromised host is usually our first task that we do. And what we're aiming to use those for are to move laterally or to access other applications that might require clear text credentials and aren't just doing Windows authentication. So there's a number of modules you can use to do this. The most popular is Mimikatz, a tool by Benjamin Delphi that will dump cache passwords from memory. And this will get both the passwords in clear text if they're on clear text on the system, and also the password hashes. DC Sync is another tool. It does require domain admin, so this is more for getting hashes for specific users. But what that tool will do is it'll request a specific user's password hash from the domain controller so that you can use that to move around the environment to different systems. And then pass the hash is a module that will take one of the hashes that you got from either Mimikatz or DC Sync, and it'll make a new process that runs as that user who the hash belongs to, and then you can use that process to essentially assume that user's privileges. And these are all of the, you can see there's a ton of different Mimikatz credential modules down here and some other ones as well. So lots of stuff you can do in Empire with credentials. All right, so we can show you some of that. That's probably the most fun to demonstrate. So the output for gathering credentials in Empire is really messy, and in Mimikatz is really messy, but it comes with this database of credentials here. So it'll automatically parse all the Mimikatz output for you and put your username, password, hash in this database for you. So if I use module credentials Mimikatz, then log on passwords is the specific module that's going to dump clear text passwords or hashes from memory. There's actually nothing to configure here, so we can just run it, and we should hopefully get some passwords back that are on the system. Also, Mimikatz is kind of large, so this generally will be one of those modules that takes longer to run than you want it to. So be patient, and hopefully you'll get some credentials back. Cool. So that's what the raw output of that Mimikatz command looks like. Like I said, it's super messy. There's all sorts of stuff in here. You can eventually see these password hashes. So you can go through here manually if you want and pull them out. But Empire stored those in their local credential database. So now we have those, and we can easily use them for other things like lateral movement. Which brings us to the last module type here, lateral movement. So there's a couple different ways that we typically move from one compromised host to the next. So one of them is called WMI, and that's the Windows Management Instrumentation. And that's basically a way for administrators to do remote management of Windows systems. And another one is called PSExec, which is just another Windows administration tool. The main difference between these two is that the PSExec method will actually create a remote service and run it on the system that you're trying to move to. And it's a very easy to spot indicator of potential malicious activity. So it tends to be really noisy. There's still situations where you might want to use it, but for the most part, using the WMI method for lateral movement is kind of our preferred method. There's a couple other lateral movement modules in here, so you can do things like invoke SQL commands if you have credentials to a SQL server that you know, or if there's a Jenkins script console out there that you know of, you can use this to move to a Jenkins server, and some other ones as well. We'll go show some of that. I also forgot to go and show you the pass the hash in DC Sync, so we'll do that real quick. So DC Sync is, like I mentioned, going to request credentials for a specific user from the domain controller. So there are a couple of things you have to set here, but the only required parameters are the agent, which if you use a module from inside of an agent already, that's going to be pre-populated for you, and then the user. So Barrett _A in the Pew domain here is another domain administrator. So he might have particular access that I don't have, and I want to get his credentials. So I can run this module, and then it should query the domain controller for Barrett A's hash, and we should see that in our credential database afterwards. Got started. All right, so similar to the regular Mimikatz output, DC sync is quite messy, but luckily its output's also put into this credential database, and you can see that we have Barrett A's password hash. You can also notice that, so this host column tells you where the credential came from. These three all came from that initial dumping of passwords on our compromised host, and this last one came from WinDC01, which is the domain controller in this demo lab. So once you have a hash, you need to do something useful with it. So you can use the pass the hash module. And that's going to take a few different parameters, but what you can do is just specify a credential ID from this creds database here, and that's going to auto-populate the domain and TLM hash and user for you. So when you run this module, what it'll do is create a cmd.exe process by default with the privileges of the user that you specify. So in this case, we're going to create a cmd.exe as R. O'Neill. Something to watch out for when you're doing a hash like this is that it will create an interactive process. So if your compromised host has a user actively on the laptop, that command prompt is going to pop up, and we can see it just pop up now over here on our remote desktop to that host. Once you have that, though, you use the process ID to inject another agent into, and then that agent will be just like this one, except it'll have the privileges of whatever user that you created it with. So once you have all the credentials, you need to move laterally. So we can use some of the lateral movement modules. Like I mentioned, invoke WMI is our favorite, and we found that it's kind of the most reliable in many cases. So parameters here, you need to set the listener, and this is going to make sure that when you move, it's going to use WMI to execute the launcher for the listener that you specify here. So in this case, it's going to execute that big PowerShell string on this host here that we've specified. So we can run this, and we should get another agent eventually. That was quick. And you can see that we've got another agent on a separate IP here, a different machine name, and we could then interact with that agent. And you'll see I did execute that lateral movement as just my current user here, so we're still Chris_A. But you can also supply credentials, and it'll try to move laterally with the credentials that you supplied. So if you want to be someone else on the new system, you can specify that. All right, so that was kind of a lot of stuff on some technical topics. So if you have questions, you can reach out to us, or we have some time for questions now. All of the activities that we did today with Empire and those compromised hosts, we were doing in one of our labs. So if you want a demo of the lab environment to practice some Empire stuff or any other C2 things, pen testing things, you can go to veery.com/cover6demo and sign up for a demo there.
Yep, and we'll just send you a link to log into a lab environment, and you can play around.
So Tyrone, thanks. Is there anything that you want from us, or does anyone have questions?
Nothing much from me. I want to thank you all for giving this great presentation. I know I learned a lot. I want to thank everyone else that attended the webinar. Thank you all for being here. It was great. Definitely check out the demo. Definitely get Chris and Barrett's information in case you want to reach back out to them for any questions. Like I said, the video will be posted to the website and our YouTube channel. We look forward to great things from Uberry, and thank you all once again.
Thanks everyone for coming today.
All right. Have a great day, everyone.